Hello and welcome back, Tech Stalkers. Today's video will be about parabolas. We will explore many aspects of parabolas. So, as you can see in front of you, this table is very important when dealing with parabolas. In this video, I hope I will make it clear and simple. Um, we will solve 3 examples, and I might leave a link to a worksheet down below. I'll think about that. And yeah, let's start. So for parabolas, what is a parabola? A parabola is an is the graph that looks like a curve, okay? A curve. Okay. So this is a curve. But to graph this curve, which obviously has an equation, we need many information. And we get those information from this table. So we have the opening, the vertex, the axis of symmetry, the focus, the directrix, and the length of the lattice rectum. So for most of you, or not most of you, so for some of you, let's say, this is too much, okay? So explaining this in one video would not work for them. So what I would recommend, if you don't want to get into too much details, is to memorize this table or copy and paste it in your head if you don't want to overthink it, but you just need to know what to use or where to graph each thing. For example, you need to know where is the lattice rectum, or where is the directrix, where is the focus. You can do that. But for those people that want to actually know what does each thing mean specifically, and some techniques to use them, um, here we go. So for example, first of all, we have the form of equation. So this is a key thing about parabolas. We have parabolas like this and parabolas like this. So the difference between these two is, as I said in the previous video, the axis of symmetry is vertical here, but it's horizontal here. The second aspect of the parabola, as I said, each parabola can have a maximum or a minimum. That's in the case of the uh, vertical parabola. So the second aspect is the direction of the opening. So this could be up and down, or left and right. So let's take a look at the equation. For vertical parabola, we have the standard form y equal a into the bracket x minus h squared plus k. Now remember, h is the translation of units left and right horizontally, and k is the translation up and down. Now, if we look at the second equation for horizontal parabola, we can say that h and k switch places, right? So this is the difference between the two equations. Now, that's what you need to look for when before identifying the direction of the opening. So if it's in this standard form, if the a is greater than 0, the graph will open upward. The curve will open upward. If it's less than 0, let's say a here is -2, it will open downward. right? If you see an equation that's similar to this one, if the a is greater than 0, that means the parabola opens to the right. If it's less than 0, the parabola opens to the left. And then the third aspect is the vertex. So the vertex form is H and K, H, K, okay? However, as you can see, the H and K swap places in the horizontal parabola. Well, you need to watch out every single time you're like solving an equation, solving um, problems and graphing parabolas. You need to first of all identify if it's a vertical one or a horizontal one. So in this case, you will swap places. Um, it will swap places, but it will stay in the form HK. Okay, so watch out. The axis of symmetry. So I have a okay, that was a good cold breeze. For the axis of symmetry, when we say, let me just erase all of this. Oh my gosh, I erased the question, removed the question. All right, so we know that x equals h. Okay, sorry, we have the expression x minus h. So we will know that x always comes with h, right? So for it will not equal k, for example. Okay, this is wrong. Okay, so this is like a trick to remember it. So x is always comes with h and y comes with k. All right, so x and h are together. So when we're talking about the axis of symmetry, x equals h. So we know that whenever we have x equals something, right, it's going to be vertical. It's the exact, like for example, because x is the horizontal axis. When we're drawing or graphing an equation that starts with x equals, the graph is going to be vertical. Okay, if it's linear, it's going to be vertical. So if it's equal to a constant, so in this case it's equal to h. Suppose h is 5. So this will not be the graph, but it will be a straight line cutting through 5 on the x-axis. Okay, so suppose we have 5 here. The graph of this equation would be this. All right, so let's remove all of this. So whenever we have x equals something, we know this is equals a constant. We know this is a vertical line. Now let's go to the one that is horizontal. All right, so we know y and k are together, so y equals k. And here we have the reverse, okay, the opposite. Y equals, when we start something with y equals and y equals a constant like 3, for example. Let's say this is 3. Okay, the axis of symmetry is, this is not a straight line. Okay, the axis of symmetry is, will look horizontal. Okay, if we have y equals, it will look horizontal. If we have x equals, it will be vertical. Right, remember this key point. I want to keep the graph actually. Let's remove all of this. All right, so the next thing on the table is the focus. Now here's the vertex, right? The focus is a few units above the vertex. You just need to know that this is what it's called. you don't need to go into deep details because the focus mainly has to do with physics. Just remember it as the focus, and remember, as you can see here, it's this red point, it's a distance away from the vertex. All right, but they are on the same, line. Okay, so both the vertex and the focus are on the um, symmetry axis, and the same thing here, we have the vertex and the focus. Now, before going to the directrix, I want to go to the lattice rectum. All right, so the equation for the focus is this. Right, we'll come back to it once we talk about the directrix. Okay, so the length of the lattice rectum is, okay, first let's understand what is a lattice rectum. You don't really need to go into deep details, but I'll tell you, the lattice rectum is this line that cuts through the focus from one end of the parabola to the other. All right, so the length of this line, and by the way, just a fun fact, all right, the rectum is, to refer to biology, it's the end of our digestive tract, so maybe that will help you remember it. Okay, so it's just before everything comes out, so you can relate with the drawing. I don't know why do they call it that. Anyways, this is the lattice rectum going through the focus. So going back to the directrix, oh, okay, oops. All right, so going back to the directrix, so I need to remove all of this initially to explain all the directrix. You can just remember that it's a horizontal line, as you can see. If I zoomed here, it's a horizontal line below the vertex or below the curve. But if you want more details, okay, let's say this is my vertex, the dot here, this is my focus, and this is the directrix. All right, so as you can see, let's say that the distance between the focus and the vertex is d. The distance between the vertex and the line of the directrix is minus d. Okay, the d in this case here is equal to k plus 1 over 4a, and minus d is equal to k minus 1 over 4a. All right, so actually, let me remove that. I don't want you to get confused with this, and k is different, and so k is in the case of a vertical parabola. I don't want anyone to get confused, but this is generally the the directrix, if you are interested to know more about it. So now let's come to the kind of more crowded expressions in here, the focus and the directrix. All right, so let's take each, for example, equation at a time. So here for the vertical parabolas, the h is the same for the coordinates of the focus. The h is the same, but as you can see, we add 1 over 4a to the k value. All right, so I remember I just wrote that d is equal to k plus 1 over 4a. I removed it because k is not included, it's 1 over 4a only. All right, so you just add it to the k, and I'm sorry about it. And minus d is 1 over 4a minus 1 over 4a. So you plus that to your k if you are in a vertical parabola. All right, when you're finding the directrix, you minus it from your k. All right, I hope this makes it clear. Now, in the case of a horizontal parabola, the only thing is that instead of adding these to the k, we add it to the h. All right, we add it to the h. So here, as you can see, we add this 1 over 4a to the h, and we add this we subtract minus 1 over 4a from the h. This is like a simple way to remember it. All right, now let's remove all of this and take our first example. So the example says, right, y equals 2x squared minus 12x plus 6 in standard form. Identify the vertex, identify the axis of symmetry, and the direction of the opening of the parabola. First of all, let's look at the equation. Y is equal to x squared minus 12x plus 6. It is not in the standard form. We call this form, which is y equals ax squared plus bx plus c. We call this the general form, all right? Okay, the general form. So we're given a general form and we need to turn it into a standard form. So, okay, there's something that I did not mention here is the x and y switched, yeah? So this equation or this form stands with y, so we're definitely turning this to a standard form, to a vertical standard form of a vertical. All right, guys. So we took the common factor out too, and then we are going to write what's left, which is 6x plus 6. All right. So what are we going to do here is something called completing the square. Completing the square literally means making this a whole square, and this square or this power will be here. Okay, so it requires more knowledge in factorization, but I'll give you a simple method. We will do x squared minus 6x, write them as they are. So now we're going to think, what is 6 divided by 2? Yes, it's 3. Now, what is 3 squared? It's 9. Great, so now we're going to write 9, but notice that we added 9 inside the bracket, right? And it's multiplied by 2. Now we have to do plus 6 minus 2 into 9, which is 18. All right, this 18 came from 2 into 9. All right, so it's just for reference. Okay, so now we can complete. Okay, so we keep the 2 as it is. Now we're going to work with this parenthesis or this bracket. So if you see something like this, all right, after you complete the square, it's called completing the square. So we just simplify that to x minus 3 squared. So text talker, how can I know it is a minus 3? First of all, have to know if it's minus or not. You will look at the minuses and pluses. If there are two pluses, you put plus. If there are a minus and a plus, you will put minus. Where did we bring the 3 from? So look at the last bit right there, which is the 9. What is the square root of 9? Yes, it is 3. What is 6 divided by 2 is 3. So x minus 3 squared. This power is outside or on the bracket. So what is plus 6 minus 18? It's minus 12. All right, we got our standard form. This is our a, this is x, this is h, and this is k. All right, so what are they asking for? The vertex. We know that the vertex is hk, right? What is h in this equation? So when we're looking at h, we're just looking at the 3. If there's a minus, just look at the 3. If there's a plus, just take it as minus 3, all right? And the k is minus 12. If it's outside the parentheses, we look at the whole thing, minus 12, all right? So h and k, 3, comma, minus 12. This is our vertex, all right? All right. The axis of symmetry, do you remember when I said x equals h? The axis of symmetry is x equals h. So x equals 3. This is our axis of symmetry. Does it open up or down? Well, let's look at the a. The a is positive, so it opens upward, all right? Okay, good job. Now, let's move to the second example. Alright, when they say graph each equation and you don't have a graph, okay, first you will need to find everything in the table. The form of the equation, direction of opening, vertex, axis of symmetry, focus, directrix, and length of lattice rectum. This is not really important for graphing, but you just do it on the way. Alright, so let's rewrite this in standard form. So the y is the squared part here. And we have two y's. So you can conclude that this equation will end up as a horizontal parabola, right? So we start moving bits to the other side of the equation slowly. So now we have 2x equals y squared. Because when we move this minus y squared to the other side, it becomes positive y squared, right? And plus 4y normally, complete normally, plus 10, all right? So what we want to do now is we will divide everything by 2, all right? We'll divide this side by 2, this by 2, this by 2, and this by 2. What we will get is x equals y squared over 2 plus 4y over 2 plus 5. Alright, so now we will do our very easy technique as we discussed in the last example, which is we will look at this and find a common factor. Well, we just divided by 2. What is dividing by 2? Dividing by 2 is just multiplying something by 1 over 2, right? So 1 over 2 is the factor we're going to take out, right? So x equals 1 over 2. So this is y squared 1 over 2 from this. So this is like, if we simplify this, 4 over 2 is obviously 2, right? So what we'll do is 2 divided by 1 over 2 on your calculator, and you will get 4. So it is as if we did not take anything. Let's remove this line. Okay, y plus 5. Alright, and now we need to complete the square, right? So okay, when we get to this part, what is 4 divided by 2? It's 2. What is 2 squared? It is 4. Okay, and you continue as normal, plus 5. Now we need to complete the square. So now we have our a. What is the complete square of this one? Okay, so we have a minus and a plus. That means we're going to have a minus. And what is the square root of 4? It's 2. Great. And that's our perfect square. Plus, okay, we added 4 here. Okay, can you spot the error? We added 4 here. We forgot to subtract it outside, right? So 4 into 1 over 2 is, okay, I'm just going to write it, 1 over 2, all right, into 4. We multiply this by this, and then we subtract it, right? So this is plus 5 minus 2, because this is going to be 2, right? So plus 5 minus 2 is plus 3. And this is our final equation in standard form. Alright, let's find the vertex. The vertex is HK. Now remember, H and K swapped, okay? So this is going to be K and this is going to be H. If you did not understand, just refer to this equation. So H and K, this is the vertex. The H here is 3 and the K is 2. Alright? The direction of opening is going to be left or right because it, as you see, it started with X, which means it is a horizontal parabola. So it's if A is greater than 0, it's going to open to the right. If it's less than 0, it's going to open to the left. And clearly here A is 1 over 2, and this means it's going to open to the right. Alright? And then the axis of symmetry. As we discussed earlier, y equals k. So in this case, y equals 2. Alright? This is the, okay, this is the vertex. This is the A of symmetry. Okay. Now the focus is, the H will stay the same, alright? So the H will stay the same. Oh, this is in the case of the vertical parabola. You need to watch out from these errors. The K will stay the same, which is 2, and the H will be 3 plus 1 over 4 into 1 over 2, because it's 1 over 4a and a is 1 over 2. So you plug that into your calculator. 3 plus 1 over, I obviously say this because I don't want anyone to get mixed up in this process. So 4 into 1 over 2, and you will see that it is 3.5. Alright, so the focus is 3.52. Alright, okay. Now let's find the equation for the directrix. Okay, Directrix. I don't know if I wrote that in the correct way, but the k will stay the same. The only thing is, instead of plusing 1 over 4a, we will be minusing 1 over 4a. And 4 into 1 over 2 is obviously 2, so we will get 2.5 in and 2. Alright, and for the length of the lattice rectum, which I like to write it LLR for short, it's 1 over a units. Okay, modulus 1 over a unit, and this is 1 over 2, which makes it a 2. Alright, you can plug this into your calculator to check, but the LLR is 2. Alright, this is for the third example, the second example, I'm sorry. Now going for the third example, alright, so here's our third example. Writing an equation for a parabola given the vertex and the directrix. Alright, so we know the vertex or what is the vertex, right? So the vertex is, as usual, that's my phone, I'm sorry, h and k, and our h and k is -2 and -4. Now we're done with the vertex and identifying h and k. They give us now the directrix. Look back at the table. When is the directrix y equal to something? Yes, it is when we have a vertical parabola. It could be like this or like this. So for this sake, we know that y is equal to 1. We're going for this, for the sake of our problem here, we're going to look at the table, but you need to memorize all of this if you're going to write an exam and the teacher says you don't get to have the formulas in front of you. So we know that the directrix is x minus 1 over 4a. So what if we made x minus k minus 1 over 4a equal to 1, right? Because this is the formula of the directrix and this is the actual value, right? So let's solve, and now we know the value of k, right? The value of k is -4. Now we solve for a, because this is the missing part that we need in the, let's remove all of this from the previous example. This is the part that we need for us to complete the standard form. So we'll start by moving -4 to the other side. Yeah, so we're left with minus 1 over 4a equal to plus 4. Plus 4 and plus 4, these are gone. 1 plus 4 is 5. Now we will in order to remove 1 minus 1 over 4a, we're going to multiply by 4 or -4 to remove the minus sign as well. So this is gone, even this. So now we're left with a equals -20. So this is our a. Great. Now we know, let me remove all this. so we don't get confused with the solution of the last example. So now, we know now that our h is equal to, what's our h? It is minus 2 and minus 4 is the k. So minus 2 and the k is minus 4. We know that it is a vertical parabola, and we know that a is equal to minus 20. So let's put all of this in our equation. So y equals ax minus h squared plus k. Let's plug all of the values in. So a is minus 20, alright, x is 0, minus h. So h is minus 2, right? So minus and minus, we have a plus, alright? Plus 2 squared plus k. What is k? K is minus 4. Plus and minus, minus wins. So we have minus 4, alright? So this is the equation of the parabola we were given, and the parabola opens upward, downward, because a is less than 0. So that was it for today, guys. I did not go into graphing on the grid. You can use Desmos for that. You can plug this equation. Let's go. So y equals minus 20 x plus 2 squared minus 4. And this is our parabola here. This is our graph. And I will talk about graphing conic sections maybe in a later video. So that was it for today. Don't forget to subscribe and to like, so you can encourage me to make more videos. Thank you guys, and see you in the next video. I have a problem now.